Since logs are just fancy ways of writing exponents, that means that the exponent rules that we learned in algebra still apply. The three that are going to be the most important for us are first the product rule, which says if you're multiplying two things together that have the same base, keep the base, add the exponents. When you are dividing, it's going to be the reverse. The quotient rule says if you're dividing two things that have the same base, keep the base, subtract the exponents. Then the power rule says if we're raising an exponent to another exponent, you're going to multiply your exponents together. There are two other exponent rules. 0 as an exponent, anything to the 0 power is just 1, and negative exponents tell us that the base it's attached to is misplaced and should move across the fraction bar. But these three are the most important to help us with logs. Now let's look at an example of how to expand logs. Here I've got the log of two things being multiplied together. As we try to expand this, we'll need the word log once for each of the factors that I have. Since I've got a factor of x and a factor of y, we'll need the word log two separate times, once for each of the factors when we're expanding. Now these two things were being multiplied together. To handle that multiplication becomes addition when you're dealing with exponents. So let's add these things together. These are equivalent expressions. On the next one, we're dividing two things. Notice that I've changed from a common log to now I'm dealing with a natural log. These log rules, these exponent rules, apply no matter what base log you're working with. So here, as we're dividing these two things, again, I need the word log once for each of the factors that we have, this time being sure to keep natural log, since we started with natural log, and the division becomes subtraction. When you are dividing two things that are exponents, you subtract the exponents. The final rule is our power rule written as a log. It says that when we're taking the log of something and it's raised to an exponent, you can move this exponent around in front as a multiplier. That puts it on the ground with everybody else. This is going to be very important to us as we start to solve logarithmic equations because it'll help us to get the exponent down on the ground where we can deal with it. Notice that again, if I start with a base 3 log, I have to keep a base 3 log. So the base 3 log of x squared is the same as 2 times the base 3 log of x. That's how it looks as we expand, but now let's try to go the other direction and condense these expressions. You might see this as rewrite as one log. For the first one, I've added these things together. When we rewrite it as one log, that means I'll need the word log just one time in my answer. Since these things are being added, addition turns into multiplication. One log, the same kind of a log that we started with, and the two things we were taking the log of need to be multiplied. On this next one, we're doing the same thing, only now instead of having variables, it looks like we've got numbers that we're working with. The addition means multiplication. So 5 times 9 means 45. Rewriting as one log means ln of 45. We started with an ln, we keep an ln. You would be able to evaluate that further on your calculator if you were asked, but most of your homework problems just want you to rewrite it as one log. If it says rewrite as one log, then they don't mean for you to evaluate it any further. Here I've got subtraction, so subtraction should become division. Notice that it was a common log, a base of 10, so we've kept a common log. Condensing means rewrite it as one log, so the word log shows up one time in our answer, no matter how many times it was written in our question. The subtraction became division. Over here, a little bit fancier multiplication on this one. I know I'm multiplying because the two logs are being added together. As we rewrite as one log, I need the word log one time in my answer. I started with a base 10 common log, so I'm keeping a base 10 common log. As I multiplied these things together, it was a nice sum and difference, so all I had to do was x times x, the first ones, makes x squared, and 2 times negative 2, the last ones, that makes negative 4. Notice the parentheses are necessary because we're taking the log of all of that. One more, this one's maybe the trickiest one of all. Here we're raising an exponent to an exponent, since a log is just really a fancy way of writing an exponent. We can take this 3x around in front as a multiplier, and now it's down on the ground with everybody else. Now ln back here on the back, whenever you see ln, this has a value of 1. Remember that natural logs have an understood base of e. So it's saying if you take e and you raise it to the first power, you would still have just e. Anytime that you see ln, the value is 1. Here, ln becomes 1. 3x times 1 is just 3x. When you are rewriting as one log, no matter how many logs you started off with, your answer will have one log. You don't want to evaluate unless you are told to evaluate. Multiplication comes from addition. Division comes from subtraction, and exponents are moved around in front as multipliers.